Hey, hello, this is Rhett Elaine. I am going to show you not a mistake. It's not a mistake. I'm going to show you an issue that I have with numerical calculations and something that's not technically numerical calculation, but students still do it anyway. Okay, so I'm using Python here because GlowScript has some plotting issues that don't work this method. But what happens is when I tell people to do a numerical calculation, they'll say, okay, I'm going to do projectile motion. Okay. And they're going to use MATLAB or Mathematica or something like that. And they have something like this that they start off with. And it may be, the syntax may be a little bit different, but the idea is the same. They'll say t equals a range. So they set values of t. This says make some values of t between 0 and 1 in 0.01 increments. So this is a list that goes, let's do this, 0.25, okay, so there won't be that many. Now I'll print t, just so you see what it looks like. Okay, now if I run that, this is what it looks like. You see, so it made those, so you see how it works. Okay, so but I don't want to do that, and I don't want to do that, 0.01. Okay, now I'm going to start at, I'm just going to throw it straight up. Y equals 0. The initial velocity, Vy0 equals 2.4. G equals 9.8. And that's it. And then you'll say, oh, now I can calculate the y position. So y equals y naught plus Vy naught times t minus 0.5 times g times t squared. Cool, huh? Okay, and then you'd say, now I'll show you what that looks like. I'll plot t versus y, and I'll show it, and I'm going to run this, and y naught is not defined. I made an error. Y. Oops, sorry. Okay, run it again. Okay, so there's your graph. It's a parabola. Everything looks great. It's like I did it. I did a numerical calculation, but you didn't. Okay, because that is a solution for projectile motion, but it's not a numerical calculation. The idea of a numerical calculation is to break it into little steps. So let's do that. Okay. The same thing. I'm going to not have this t. So I'm going to comment that out. It's weird. It didn't comment it out. Oh, yeah, I know why. I didn't save it as .py. It likes to have it as .py. It's weird. Okay. So then I'm going to get rid of this, and oops, and I'm going to go over here. Now I do need something else. This is just a little trick. I need a list of answers to plot, which are different than my variables. So I'm going to say t equals 0 and y equals 0. I don't need the y naught anymore. Okay, I don't need the v naught anymore. That's just the initial velocity. Okay, now I do need dt. dt equals 0.01, and then that was for a second, so I'm going to do the second again. So I can say while t less than a second, do the following. First, calculate the velocity, because the acceleration doesn't change. So vy equals vy minus g times dt. Y equals y plus vy times dt. Okay, now I need to update the plotting variables. So I'm going to say TP equals TP plus the time. Oops, I didn't update the time. T equals T plus DT. Now I need to update the Y position. YP equals, that P stands for plot for me. And so by doing this, that makes it add it to the list. I'm adding this onto I'm appending it. Yeah. And that's it. Now I need to go down here. This needs to be YP TP, and it might run, but it might not. It ran. Okay, yeah. And you get the same thing. And so you may say, well, you get the same thing, it's the same thing. It's not the same thing. Because what if I go back over here and I want to include air resistance? If I want to include air resistance, I can calculate the force and the momentum and add that stuff in here. But this way, you can't, because it's not breaking into little steps. So, I mean, this problem is simple, and you would probably just do it on paper. But it's practice for real numerical calculations. And that's why just making values of t and calculating the y is not a numerical calculation. And that's all I have to say about that.